Okay, this is the definite integral number 2, and if you saw the video for number 1, it's very much the same process. What the difference is, now we have an x and an x cubed instead of before we had the x squared. So there's different summation formulas that you would find in the book that you would use, or just do a quick search on Google is what I did to come up with the formulas. And they are, you have that sum as k goes from 1 to n of k, excuse me, that's just going to be n times n plus 1 over 2. And if you have the sum as k goes from 1 to n of k cubed, that's going to be n squared times n squared plus 1 over 2. So we'll be making quick use of this in a few minutes. Now, our interval is 0 to 1, so our delta x is going to be 1 minus 0 over n, so it's 1 over n. And our c sub k, as they ask for, which is the right endpoint, is going to be 0 plus the delta x 1 over n times k. And if we begin our interval or our summation at 1, that's going to be the right side of the interval, because here's 0, then here's 1, where these are the k values. And so when you have an interval, here's the right side for the first one, the second one, and so on. So what we're looking for, it's the same process. We're looking for the limit as n goes to infinity of the sum as k equals 1 through n of f of c sub k times our delta x. So that's going to be the limit as n goes to infinity of the sum as k goes from 1 to n of f of, I should have finished this off, k over n, f of k over n times 1 over n. So we end up with the limit as n goes to infinity of the sum. Now this k over n is going to replace the x in this 17x plus 17x cubed. So it's going to be 17 times k over n plus 17 times k over n cubed. So we have the limit as n goes to infinity. I forgot my k equals 1 to n. Sum as k equals 1 to n. K. There we go. Of 17k over n plus 17k cubed over n cubed. And I forgot my 1 over n here, but I'm going to just pull that over to this part because it's not affected by the k. Next, we have, I'm just going to take the limit now as n goes to infinity of 1 over n and separate these summations. So do the sum as k equals 1 to n of 17k over n plus the sum as k goes from 1 to n of 17k cubed over n cubed. That's going to give us the limit as n goes to infinity of 1 over n times, and then we have 17 over n times the sum as k goes from 1 to n of k plus 17 over n cubed times the sum as k goes from 1 to n of k cubed. So this is where these formulas from above are going to come into play, these two formulas here and here. So we have this limit as n goes to infinity of 1 over n times, we have 17 over n times the sum as k goes from 1 to n of k. It's just going to be n times n plus 1 over 2. And then we have 17 over n cubed times the sum as k goes from 1 to n of k cubed is n squared plus, times n squared plus 1 all over 4. Now we're kind of getting somewhere. So we got rid of the summations. Now we're down to these n's, and we're going to, as n goes to infinity. So we're going to simplify some things out. And just as we saw before, we end up in several cases where the n in the denominator is more than the n in the numerator. So it ends up going to infinity in the denominator, meaning the fraction goes to 0. Okay, so we have the limit as n goes to infinity of, I'm going to bring this 1 over n into each of these now, 17 over n squared. I'm going to bring this 2 over here as well, 2n squared, times n squared plus n, plus 17 over 4n to the 4th, because that's n times the n cubed, makes n to the 4th, times n to the 4th plus n squared. Okay, now we take this to the next step. We have the limit as n goes to infinity of 17 over 2. Now watch what I do here. I'm going to take this n and make it a denominator for each of these of n squared over n squared plus n over n squared plus 17 over 4 times, and then bring that n to the 4th n to the 4th over n to the 4th plus n squared over n to the 4th. So we have the result that these divide out, leaves a 1. Here leaves an n down below. These divide out, leaves a 1. And here we have an n squared. So if we look at this limit, wrong color. The limit as n goes to infinity of, so this is 17 over 2 plus the limit as n goes to infinity of 17 over 2n plus the limit as n goes to infinity of 17 over 4 plus the limit as n goes to infinity of 17 over 4n squared from here. Okay, so if we look at each of these, this first one, that's just as n goes to infinity, 17 halves is not changed. In the second case, as n goes to infinity, this part in the denominator is going to infinity, so something over infinity, a constant over infinity, is going to be 0, so plus 0. Then we have the limit as n goes to infinity of 17 fourths is just 17 fourths. And then we have the limit as n goes to infinity of 17 over 4n squared. So that denominator is going to infinity squared, which is infinity. And that's getting infinitely big over or under a constant. So that's another 0. So we end up with 34 over 4, that's 17 halves, plus 17 over 4 gives us 51 over 4, which, if you recall from the beginning, is our answer. Okay. Hope that helps.